Okay, shall we start? Okay, hello everybody. Today I'm going to talk about setting up three linear systems for U, V, and pressure correction equations, respectively. Let's start from U control volume equations. Here we have a control volume P, where I draw two solid lines, W and E faces. I had two dashed lines for north and south faces. And if we use the two-dimensional index as denoted in the textbook, P will be I and J. And W phase will be I minus 1 and capital J. And E phase will have the indices I and J. So for the south phase, we have small I, small j, so on and so forth. Okay, so with those notations, we can try to set up a linear system like this. So APUP will be the summation of A neighbor, U neighbor, plus PW minus PE times AP. Okay, so here AP, if we use 2D indices, it's going to be AIJ, UIJ, plus sigma summation of A neighbor, U neighbor, plus Pi minus 1J minus Pij. The area will be the volume of this P cell divided by Xi minus Xi minus 1. Okay, let's try to define the A neighbor coefficients one by one. If we start AW, capital W, that will be dW plus maximum of FW 0. So here I use the second order central difference scheme for computing the convective fluxes, and I use the upwind scheme for computing the convective fluxes. So similarly for AE, I have dE plus maximum minus FE 0. Okay, so AS will be, so this is capital S, AS plus maximum FS 0. And A north will be and this is D. This is again D. Maximum F and 0. Okay, so once we are able to, here we will have a negative sign. Once we are able to write the neighboring coefficients in this form, we need to compute D and F terms. So let's start from FW. FW is rho U A W. So suppose U rho as a constant and A W can be easily computed if we use uniform grid. Then we can compute UW. UW, we have self-centered value here, and we have a self-centered value on the left, but we don't really know the value on the W face, so we do an average. So that is UW plus UP. Okay, so here similarly, FE is rho U A E, that will be rho E A E, and do an average again. So UP plus UE divided by 2. Alright, so now let's try to compute the convective flux for north face and south face more carefully. So rho V A N, we have rho N A N. So for V, if we look at the north face, we have V over here available, V over there available. So in order to get the face center, we'll just compute the average. So that will be V I minus 1 J plus 1 plus VI J divided by 2. This is J plus 1. Okay, for Fs, we have rho S A S V I minus 1 J plus V I J divided by 2. So that is the average of this point and that point, where we evaluate the V velocity components. Okay, F term can be computed like that. Now, what is remaining is to compute D coefficients. So let's start from dW. dW will be, by using diffusive coefficient for U momentum equation, that will be the viscosity and times the area of W divided by delta x distance between W and P point. Okay, if we use the uniform mesh, that will give us mu delta y over delta x. Okay, so similarly, dE will be mu AE divided by delta x PE, that is mu delta y over delta x again. Okay, so ds dn can be computed like this if we have a uniform grid delta x over delta y. Okay, so now all D and F terms are computed. Now we can compute all neighboring coefficients for A, and for AP we have this relation. AP is the summation of A neighbor plus delta F, where delta F is simply Fe minus Fw plus Fn minus Fs. Okay, if we treat pressure as guessed values and then this product as SU term, then we can easily set up linear equations for all U control volumes. All right, so now let's move on to V control volumes. So for V control volume in the staggered grid, so we will have two solid lines on top and bottom, but on the side we will have dashed lines. So I'm going to draw dashed lines with a different color. All right, so now the cell centroid is again P, and we have W, we have E, north and south. All right, so let's take a look at now the two-dimensional indices for P. There will be I, which is capital letter, and J is a lowercase letter instead. All right, so for W phase, we have I, J. East phase, we have I plus 1, J. North phase, we have I, J, and south phase, the index will be I minus 1, J. I and J minus 1. I and J minus 1. All right, So after denoting the indices, basically the coordinates for the cell centroid and the faces, we can write now the linear system for this particular V control volume. So we have AP VP is the summation of A neighbor V neighbor plus the product of PS minus PN times AP. Okay. So here AP will be, so if I denote AP is the volume of the cell divided by the delta Y. So delta Y is simply the YN, which is YJ minus YJ minus 1. All right, so again, let's try to compute each A neighbor coefficient. So let's start from AW. AW is DW plus maximum FW. And the form is identical to where we used for the U control volume. I'm going to quickly write them. dE plus maximum FE negative sign and A north dN plus maximum negative sign Fn 0 and AS is ds plus maximum sign Fs 0. Okay, let's start from Fw calculation. Is rho UAW, rho WAW. Here now, let's take a look at how to compute UW. So UW here, we have UW over here, UW on the left bottom corner as well. So we can compute them as an average for the face center as UW. That will be the UIJ plus UIJ minus 1. So similarly for FE will be rho E AE UI plus 1 J plus UI plus 1 J minus 1 divided by 2. Okay, so now Fn will be rho NaN and Vn. So rho NaN and Vn. And Vn over here, we know the Vn from Vp from the cell centroid, and we know V capital N on the top. So now that would be the average. Can do an average of Vij plus Vij plus 1. All right. So similarly, Fs will be rho SAS Vi J plus Vij minus 1 divided by 2. Okay, so all F terms are computed. Now let's compute dW, which is mu AW divided by x delta x will be the delta x W So the coefficients for these will be similar to what we had for the U control volume. And this will be mu delta y over delta x. And similarly, you have dE, which is mu AE divided by delta x PE, and that will be mu delta y over delta x again. Okay, so now we're gonna have dN is ds mu delta x over delta y instead. Okay. So having all d coefficients and f computed, so we will be able to compute all a neighbor coefficients. And with all a neighbor coefficients, we can try to now compute the AP coefficient. So AP will be the summation of a neighbor plus delta f. Okay, so recall that we define delta f as fe minus fw plus fn minus fs. Okay, so you see that now all a coefficients are computed, and for ps and pn we can simply use the guessed values and treat this entire term as a source term. So now we have the linear equations for all V control volumes as well. So finally, let's move to the linear systems for the P prime equations. So for pressure correction equations, we're gonna use the scalar control volumes. And the scalar control volume will have four faces all joined with dashed lines. And so I'm going to change this title as a scalar control volume. Okay, so now the P corresponds to I and J, and W phase corresponds to I, J, and east phase I plus 1J. North phase is I, J plus 1, and south phase I, J. Okay, so once we define self-centroid on all faces with 2D indices, we find the stencil for this particular scalar control volume. So now we can try to set up one linear equation for this control volume in terms of the pressure correction. So what we have is AP P prime is summation of a neighbor P prime neighbor plus B. All right, so again, let's try to define one a neighbor coefficient that start from AW, and that will be rho dA W. We have rho W AW times dW. So dW is defined as rho W AW. So that is the AW times the AIJ from the U momentum equation. So this AP coefficient from the U momentum equation with respect to that U control volume IJ will be the denominator over here. Okay, the numerator is simply the area of that. All right, So with that, we can compute AW coefficients for AE coefficients. Similarly, we have rho dA E, that is rho E AE divided by A I plus 1J from U momentum equation. Okay, let's continue to define A north. Rho dA small n, and rho n an divided by A I j plus 1 from the V momentum equation. AS is rho dA S, so rho S AS divided by A I j from the V momentum equation. Okay, so for the pressure correction equation, once we have all those neighboring coefficients, the AP coefficient is simply the summation of A neighbors. And now the source term B is defined as delta F star, but with a negative sign. Okay? That is FW star minus FE star plus F south star minus Fn star. Okay, so one advantage of having staggered meshes is that for this P prime control volume, we readily have all velocity components available on the faces directly, so that we do not really need to do any interpolation over there. So that will be rho W, AW, and UW star. And now for W is IJ, is a U control volume cell centroid, plus minus rho E AE. For E is again a U control volume centroid, UI plus 1J star. Okay, now plus F S will be rho S AS, and then VS, if we use the two indices over there, I and J, minus rho N A N V. So use the two dimensional indices over there, I and J plus 1. That is from the previous guessed values, from previous iteration available values. Okay, you can see now all three kinds of linear equations can be set up, and if we do not consider boundary conditions. Okay, that will be it for today, and see you next time.